small slot, so I'll just get started. My name's Andy Doan. I work in the Linaro Technologies division, and I want to talk about a new CI server that we've been working on to run all the LTD CI. Can you go ahead and, oh, I've got it here, huh? All right, perfect. So this is just a quick about me. Basically, I've been fighting CI and automation for over 7 years now. I don't think that necessarily makes me an expert on deciding that I could create a new CI system, but I do know all the bad ways of how not to do one. So I think the first question that everyone's going to have is, why are you crazy enough to create a new CI server? There's 100 of them out there, and why are you doing your own? So there's actually a link on there. I'll just kind of go through it off what that link was. It's on the README to our thing, but we just had a few, what I would say, simple requirements for a CI system in our division and the company that we're going to be creating. And the first one was we needed to scale horizontally. We want to just be able to throw out multiple workers on this, or multiple front ends, and just go them behind the load balancer, update these things in production while jobs are running, and a lot of things just don't even do that. The other thing we started to see is like what Jenkins would call a matrix style build, which is kind of patched onto Jenkins. In our kind of line of work, and I don't know, I think everybody kind of has this, but I think that's a first-class citizen for any CI thing, because every build always has multiple, what we call runs. So we have a build, like build 12, and it's going to have multiple runs, and that's just a first-class citizen of our modeling and how we report results on builds and stuff like that. The next thing we kind of had was containers are pretty awesome now, and we just want to do as much as we can with containers being a part of the system, not kind of bolted onto the side of it. In fact, we've taken it so far now, when we build Docker, we build our Docker images inside of a Docker container. So we've just gone all out Docker on this. And when you're doing CI, one of the hard things with automation is reproducibility. And when you do so many things in the container like that, it turns out you get a lot of nice benefits from having containers. You can kind of share them, and we'll get on to some, what I call one of our killer features later on. But, and this kind of ties on to what I was saying, scale out horizontally, but we needed high availability. We're going to have people using it all the time. We don't want to have to like stop everything that's running, upgrade the system, and then let everything start running again. So those were our requirements, and we started to look around, and I think everybody is going to have the why not this system. And I talked to Fatih like an hour yesterday about all these different systems we've looked at, and none of them really do it. But I think a big thing with some of these is CI's changed a lot. Like 10 years ago, even 5 years ago, I wouldn't call it mission critical, but like in the last few months, like Ben probably gets it more than anyone, but I think when ci.linaro.org goes down, we get people complaining sooner than when get.linaro.org goes down. So this is like become a mission critical thing for us. And Jenkins, which is kind of the one we all know, it can't scale. They have this thing where they say it's HA, but it's not HA at all. I think you're better off not even doing what they call. It just makes it complex. You can't upgrade it really. Debugging's awful. Just try to go look through their code and figure out how a git clone takes place, and come back 4 hours later and give me the answer. And then plugin hell. I've started to kind of have a new mantra that when things start to tell you you've got all these plugins, except for Emacs, it's usually a bad sign for the I think instead of building plugins into things, you need to have something generic where there's APIs where you can compose on top of it. And I think that just, it makes you have a much smaller, stable core to build something with. Another one we looked at was GitLab, which that one's kind of interesting, but I want to point out, they actually have what they call a runner. It'd be a Jenkins slave in our terms, or what we call a worker in the Jobserv. Their runner is 750,000 lines of code, and mine's 1,400 right now. And so it's code I wrote, so of course it seems easy to me, but still 1,400 is pretty easy for anybody to wrap their mind around. Our entire source code right now is 8,000, so this is a small project and it's doing a lot of things. Ironically, I think the most interesting CI project out there is this thing called BuildBot, if you guys have seen it. It's all Python. They actually kind of have an HA mode into it, and I went kind of deep into that. I actually started doing some prototypes of what I thought a CI. The BuildBot motto is sort of we're the nuts and bolts to make a CI system with, and it was pretty close, but I got the feeling like the things I would want to change, BuildBot would never want, and we would just wind up with this Frankenstein BuildBot code base that we didn't like the compromises we were making, and no one would ever want the upstream changes. So, and then the final kind of thing, this is always my first litmus test of any CI system I look at is the server initiating the connection down to the worker. And as soon as you're doing that, to me, it's just broke by design, because you've got some stateful thing going on, so you can't scale your system. Failures are really hard to recover from. So the way we do everything in the Jobserv is a completely pole model. So our workers can actually be behind private networks. You just have to have the server on a public network, and they poll like every 15 seconds. Hey, do I have any work to do? And we give them work. It's just a simple HTTP request. And then when our workers actually run something, instead of just having a constant SSH connection to the server where every single line of standard out is streaming to the server, I call it a streamish protocol. We go every 15 seconds or I think 1,000 bytes. It's kind of an arbitrary number, but I buffer things up. I do an HTTP post, and then it kind of shows up. So if you're just sitting there watching the live output of the logs, it pretty much looks like it's real time, but it's not. And the big advantage of that is, so if I get like a 500 error, some infrastructure thing on one post, I just say, all right, I'll just keep that data, and then 15 seconds later, I'll just post twice as much. And eventually, everything's going to get up to the server, and that worker doesn't care that I'm doing maintenance updates or whatever. And then the last thing that we built onto this thing, which I think is the cool, oh, go ahead, Neil. Yeah, we did. I think I would have preferred, if we were going to do message queuing, I actually would probably go Rabbit, just because I kind of bought into their HA story a little bit more, but I've actually avoided message queuing, and part of it is when these workers are pulling up, well, I was like, man, we kind of want to have semi-untrusted workers. I'll kind of talk about that in a second. And if you're always having to give out queue stuff, it got a little complicated, I thought, and it just seems so easy for somebody to go up to a server, look for a few, a few rows in a database, and if it says, hey, this is queued, and you meet the right criteria, just give them the job. I'm not against a message queue, but I don't think we've needed one until now, and we're surviving. But I do wonder if we ever scale to a certain size, if that database, that's going to be our first bottleneck when we hit internet scale. And like I was saying, we've built this thing called a simulator into the Jobserv, which is really interesting. So because all the runs that take place for what we call a build happen in Docker, you can actually pretty much replicate that on your home system. So the first few lines of output to any of our builds actually say, grab this file, run this script, and you recreate that build from home. And what's really nice with that is, one of the things that we don't have, I kind of left that off of the slide earlier, we don't really have much of a UI right now. It's just actually REST APIs, all that's in the core code. But I kind of hit this idea at one point, and this is a little extreme, but I kind of like to keep it as a guiding principle. If your users are using a CI interface, I think your CI system's failing you. CI is there to tell you stuff. It's not there to use a fancy GUI all the time. And I think 90% of what people are doing in Jenkins is just changing a line of code and then hitting rebuild and praying that the thing finally works. And with the simulator, you can test and iterate at home, and then once you get your job right, say, all right, let's send this thing to production and move on. So benefits for the user, I think the simulator is actually really neat. And another interesting part about the simulator is actually the runner. I just pass a flag to it and say, don't send things to the server while you're doing it. But it does just almost exactly what the system would do in production. Again, 8,000 lines of code. I think that's pretty easy for anybody to wrap their mind around. This is kind of a side thing, but I think we're doing it in Python, and a lot of these new systems are doing it in Go, and I actually think Go is really cool, but for certain open source projects, I think Python's still really great, where I can log on to a production server or my test server while it's running, add a print statement, see what's going on. And with Go, it makes it a little bit harder. And I mean, I kind of remember like the original Juju Canonical was doing was in Python. And I had a hard time wrapping my mind around that system. And I would just jump in, add a print statement. Oh, now I get it. And when they moved to Go, what I found myself having to do was go ask them for help a lot more because I was too lazy to apt-get the source, build it, restart it. It was just too much work to me. So I think doing it in Python actually has a really big advantage for people that want to tinker and get their hands on this. The benefits for the admins, it scales horizontally, which is what people need. We throw things behind a load balancer, we can scale up, scale down. We actually use Kubernetes to do everything, which is a pretty amazing system to manage things with. So we roll out what they call a deployment. We basically put a new Docker image on one thing. It says, yeah, this one's running, so I'll do it on the next thing. Or if the first one fails, it stops. So you have these rolling updates. There's really, we've tried to make it with no single point of failure. In our cloud, we use NFS, so as a run's taking place, that server's gathering all these log files. I've got to store them somewhere before I can, when the run's finally finished, I can put that log file in something like a S3 bucket or the Google buckets. But while it's streaming, I need local file systems. So we use NFS because all these workers need to be able to cat to the same file. So NFS is our single point of failure right now, but if you wanted to knock yourself out, there's Gluster and Ceph and all those kinds of things. MySQL is what we're using for our database. That can be, but I'm actually rolling out a new deployment of all of our stuff now where we're using Galera. So we've got three MySQL servers behind a load balancer, and it's just doing everything. So we pretty much have no downtime can take place for us. Because we're kind of doing this microservice, cloud, amazing architecture, it is kind of handy with the multiple daemons now. So like, I kind of remember, like a common thing I have with Jenkins is someone's like, hey, the Git poller isn't working today. Why is that? And you go tail the Jenkins log, and it's just, thousands of null pointer exceptions in Java because no one catches those. And with this, at least, I'm not saying that we don't have exceptions at times, but you can just go look at the Git poller log in our service and figure out what's going on. So like understanding that, it also kind of gives you, kind of like top capability. What's the thing on here that's going slow? And Java has those things, but you got to get like Java Melody. It's just hard with kind of the Unix multiple daemon ways. Just works great. Like I said, live updates. We do these all the time. I actually, ironically, sometimes I'm live updating something on a pull request that I'm doing. So I've got like all this stuff going, but I just believe in it now, and I know it's not going to fail. I think this is actually a really interesting thing for somewhere like Linaro, anywhere where money matters, is we're starting to do what I'm calling surge workers. And where we got this idea last week was we were kind of trying to work through a release, and our build queue was just getting really huge. And we only have 2 x86 builders in Hetzner right now. So they were just, the queue was just growing too fast. So what we did at the time was we just added some of our home systems. And since it's Docker, you can really trust someone's home computer to do it. It works pretty fine. So what we've decided to do, and I haven't quite got this merged yet, but the idea is we're going to add workers into our pool and mark them as like a surge worker or some better word. And what the scheduler is going to do, those surge workers, instead of polling every 15 seconds, I'm going to have them poll like once a minute. But what they'll do under normal loads is we'll just never give them work. But when like the ratio of workers to number of runs gets too high, we'll say, you know what, all right, we'll let this guy who's kind of just volunteering spare cycles on his computer handle some builds for us. And, you know, we try not to abuse you. And we don't want to use those all the time. We want to use our official things. It's a little more consistent. But it's kind of handy when things get out of hand like that. And, you know, I would think maybe people would say, well, why don't you spin up an AWS instance on spot? But Amazon's really not good for, you need bare metal for CI building. I think Linaro's learned that over time. And you don't want to have to, you can't go out and buy a Hetzner server for 2 hours. It's just having everybody just say, oh, yeah, I can use my computer if things get out of hand. I think that's kind of a cool thing. This is where things fall apart. We don't have a laptop to do the actual cool part. I was going to show you guys like what our example projects look like. So we have what we call projects. It would be kind of the equivalent of a job in Jenkins, but we have a YAML definition syntax for that. And we have a lot of different examples for how you build those things up. I'm not real sure how I can talk to it without actually showing those. So.
We could probably link through
Yeah, how are we on time actually right now? While they look at that, does anyone have any questions at this point? Yeah, I don't know if you got the question. He's saying, you know, can you kind of do one-off builds with it? Tyler has come up with kind of an interesting way to use or abuse our system. And so most of our projects we're doing right now are on GitHub, so pull requests trigger CI. So what we do sometimes is just put up a pull request that says, do not merge, just for testing. Or we also have actually a pretty interesting project. So, oh, thanks. So, like building Zephyr and MCU boot and all these different things, we kind of have this manifest of a bunch of repos that you have to build that are pinned down. And we actually sometimes, if you want to do kind of a full end-to-end test of our whole thing, which is really hard, and it's got to run in, you know, Tyler's Lava thing at his house, you can send pull requests to this one repo, and then it's a really easy way, like if you've got a big disruptive change that crosses multiple repos, you can basically take, you know, pin that manifest across all those, submit a pull request, say don't merge it, and then you get a full end-to-end test of it. So it's actually really handy.
So something else handy to talk about, you can also just run the simulator locally to reproduce those one-off builds. So if you don't want to use the actual CI infrastructure, you can run that same. Yeah, exactly.
Yeah. Yeah, that's actually one way. I think Tyler and I both kind of got at it. At one point, when we were starting to do some OE builds, and setting up that build environment was kind of a pain. So we actually kind of, you know, the simulator kind of leaves some artifacts around. If you're sufficiently clever, you can be like, oh, I'm just going to change this one file, and just basically we do OE builds from that at home, and we don't bother trying to learn how to build open embedded. So yeah, here's like a quick, and you can see at the top there, I kind of show like how you can actually run that thing in GitHub, or under the simulator. But this is our basic syntax. So everything has a timeout for a run. So you get 5 minutes for that thing to go, or the job, the worker that's doing it's just going to kill the thing. And then everything has, this kind of evolved over time, but everything is triggered by something, we've kind of realized. So for us right now, there's two kinds of triggers we get. Well, actually three. We do GitLab pull request, GitHub pull request, and we also pull like upstream Git repos, and when we see a like a new commit's gone in, we can kick things off. So this one is, shows just how like you'd set one up for like GitHub pull requests. And you can see there, I defined 2 runs. So you'll have, if a build of this takes place, it's kind of like a matrixy thing. You would have a Flake 8 run that takes place in a unit test. And all we say is, I need this container to execute my stuff. And then you can see each run has a script that it needs to execute. So the Flake 8 one does one thing, the unit test does the other. Let's see if I can...
Can you show a pull request?
Oh, actually show a pull request?
Yeah, there's one open right now. I'm just curious if you could sheet like what the Flake 8 run looks like. Yeah, there you go. This is the solution.
Thing is, this is going to give
Oh, this is yeah.
sorry, this is hard for me to look at. And
Yeah, this one doesn't have the window set up, right? For the,
it does. It's, I think it's under there. Well, the problem is, actually, once we show it, it's going to be a login link, so it's not going to be too hard.
but basically what it'll do is it comments on the GitHub pull request with the results, and you'll see that as part of the UI.
So,
How would you handle the case that you have plenty similar jobs that differ just with...
yeah, so that's actually the file I was going to show now. At first when we did it, we were very conservative on how we'd add features because just with that first thing, you can actually do a lot, but what Tyler and I would find is we were repeating ourselves on certain things. And one thing here was, like you said, you basically just want to change one parameter. Like I want to build K64, nitrogen, and carbon. So what we came up with is this stanza there on line 27, the loop on. So that run actually explodes into, as you see in the comments, actually 2 runs. And they just differ by, in this case, that parameter that would be board, which becomes an environment variable in your script when you're being executed. So that's how we deal with, yeah, exactly. And that's, you can actually do multiple, you can see like param values, you could actually do board, and then you could say like tool chain or compiler or whatever, and it makes, n-dimensional kind of matrix for you. And then I was going to show another example. This is going to be kind of the easiest thing. So here's how we build Docker. We have how we build Docker containers. Set a flag called privileged is true, which is kind of a Docker thing. And there's actually a container, a Docker and Docker. So we build Docker images with that now. And then there's one other kind of handy one that we've used some. This became handy with open embedded builds. So some of the builds that take so long, you want like a C cache or some kind of persistent thing to kind of keep from the last run. So we've kind of named this thing persistent volumes, and that volume gets bind mounted into your container when you're running so that you can like kind of cache things over time if you have a build and you want to like share the cache or whatever.
Is that shared across workers, or is just one worker?
Each worker's got to build up their own cache. I've kind of envisioned maybe like NFSing them if you wanted to do that in some situation, but no, it got really hard to think of anything better.
What happens if you have a couple of projects that use the same script, for example? Because right now you have to embed the script.
So we found ourselves repeating on that a lot also. I wasn't going to show that one, but we found ourselves, not only that, but in that script stanza, we were having to clone private repos. So you had to be really careful how you were doing that. You didn't want to leak the token of standard out. So Tyler and I came up with this, what we call script repo. So instead of specifying a script in this job, we say the script is going to come from a repo. And that's the relative path in that repo to it. And then down here in the script repos, I've got a name here. So clone from this. There's also two other options, like you could pin it to a specific Git ref. That could be a tag, a branch, whatever. And you can also optionally provide like a token, because like we needed that for private repos. So that's actually what we started it. When we first started, we used that script, and we were trying to get it as minimal as possible and say, just call this other one, but even that was blowing up on us. So we use that for everything now, the script repos mechanism. And I'm sure we're probably low on time, and I can't really show you a good demo of it. What's that, Tom?
Yeah, 1 minute.
So if anybody has any questions or what, I mean, kind of what I was hoping from this is maybe someone thinks that we're not that crazy and might want to kind of look at it. And I'd be happy to talk to you guys like on the side, sit down and kind of show it to you and run through it. So anybody that's interested, I mean, I fear this is going to be just something I may do on my own, but it's pretty cool. I mean, bottom line is it works right now. It's working really well for us. So.
Is the Docker Compose
Yeah, so yeah, that's actually so that was what I was going to demo, in fact, is we include a Docker Compose file, and this is not intended for production, but it gets you something going really fast. So the demo I was going to do was actually just Docker Compose up from scratch, add a worker, kick off a build, and I think I timed it. I could do that whole thing in 5 minutes. So, and there is in the docs a nice way to help you get started. The documentation is very weak on this right now, since it's just been our own, it's just hard to justify me spending much time on it. This will go through, launch the thing with Docker. It's how you get a register worker. You can enlist a worker, you set up a project, and then this kind of shows you how to like trick it into forcing a build so you don't have to wait for that repo to like change. So that's kind of a nice quick way to get your feet wet with this, and see if it's something that's interesting to you. All right. Oh.
case demo Friday.
Yeah, we can get something going by Friday, I would think. Yeah, yeah, exactly. Just look at my laptop. Well, anyways, thanks, guys. Appreciate it.